In this video, we'll be looking at repetition statements in C#. I have already created the project, and this time the project's name is repetition statements, and I have already set up the comments to guide what we will be looking at. You may pause the video here and go ahead and create the project and set up your code file to look like mine. Now, we've already reviewed two control structures. We looked at sequence, where that is the order in which the code will execute. So from top to bottom, the way you write it, the way it will be executed. Then we looked at selection, where we get to a situation where we need to compare two values and then take an action based on the outcome of that comparison, and that selection or making a decision. So now we're going to look at how we repeat an action without having to type the line more than once. So in our previous example where we were looking at selection, and I'm just going to go over to my condition statements project and click on that program.cs, we printed the same line 4 times. We literally wrote this line 4 times. Now there's a way that I can repeat this action without needing to repeat the line, because now if I wanted to change the sentence, then I have to manually go in and change it 4 different times. Whereas if I could repeat printing this sentence 4 times without changing the sentence, or rather repeat it 4 times, but then I need to change the sentence, then I would only need to change the sentence once, but it would still go 4 times. So that's the advantage that loops bring to us, the ability to repeat an action. So you see that I have outlined 3 types of loops that we'll be looking at today. There is a 4th, and I think there's also a 5th, but then for now, I'm just looking at these 3 because these 3 are mainstays and they're in every single language that you'll ever do. And the other one kind of has special applications, which we'll be looking at later on. So the for loop is what we call a counter-controlled loop. So counter-controlled meaning I am setting the number of times that I want this repetition for. So if I wanted something to happen for 5 times, then I can specify that I want it to happen 5 times, no fewer and no more. So let us look at the syntax for a for loop. So it starts off with the keyword for, and then we open parentheses, and then inside of the parentheses, we have a few things that we need to do. One, we need to define what we call the counter. So a counter is going to keep track of the number of times it is being executed. So we need to make the counter have a base value, and I'm just going to say I is short for iteration. It doesn't really matter. Your counter variable can have any name. You could call it count, but just make sure you have a variable there. So I'm calling it I. So int I is equal to 0. So I'm initializing my counter to something that is very basic, very low in value, and I'm starting it at 0. Then I have a semicolon. Then I say I less than, and then I'm going to give it the value that it should always run to be less than. So here's where it can get tricky, and I'm going to try my best to explain it so that you understand why it's going to be written this way. So I'm going to say I, which is going to have an initial value of 0, less than 5, and then semicolon again, and then I plus plus. Now let me explain what's happening here. So I have a counter and I'm initializing it to 0. Then I have a condition where I'm saying repeat as long as this condition is, well, as long as it's met, then continue to repeat yourself. And then I have this section, which is the incrementing, saying that the counter variable is counting how many times it runs. So I want it to run 5 times. So on the first run, it will have a value of 0. Then it will do the comparison and say 0 is less than 5. Okay. Then it runs and then it increments. So now I is 1. Then it compares, is 1 less than 5? It is. Then it runs again. And then it will do that and do that until we get to I being equal to 5. And then it will check if 5 is less than 5, which we all know is not true. 5 is not less than 5. 5 is equal to 5. So then it will exit the loop. Now you're probably wondering, okay, so why the 0 and why compare till it's less than 5? Well, if you put your hand out right now and do the math and you count 0, that's 1 finger, 1, 2, 3, 4, then you would have counted all 5 fingers on your hand. So it's typical practice to actually start off your counter at 0 and then just let the comparison run it until it is less than the number that you wish to stop at, right? The alternative would be if I started this at 1, then I would have to change my condition to say that I should be less than or equal to 5. So we would have looked at the less than or equal very, very briefly in the selection section. But what I'm trying to point out is that typically, if you look at any other example, if you pause this video and go and Google a for loop example, you're going to see more often than not that they initialize the counter to 0 and then they make the condition run until it is less than the intended number of executions. So it is 0, then turns to 1, then it turns to 2, then it turns to 3, then it turns to 4. At the point it turns to 4, the loop would have executed 5 times. So when it becomes 5, it does this comparison and realizes that this is now violated, and then it will exit the loop. So that is part 1 of writing our for loop. So then after we do that, then we need our braces. So you notice that curly braces are like a mainstay. Functions need them, if statements need them, and now we see that loops need them, right? So whatever we write inside of the curly braces would constitute the action that is being done each time. So let us say I wanted to print I am a winner 5 times. So I'm going to say console.writeLine. Right line, and then the text I'm writing to the screen is I am a winner with an exclamation sign in case the all caps wasn't clear enough. All right, so I am a winner and I want that printed 5 times to the screen. So remember that when in the earlier example I did it manually by writing the line multiple times. This time I'm writing it once, but I want it to print out 5 times. So I'm going to just switch my startup project quickly to repetition statements, and then we're going to look at this and see how many times it's going to print. All right, so then we see I am a winner being printed 5 times. So this was the time it got printed while I was 0. And then it went around. So it did the action, then it hit the curly brace, then it came back to 1 increment. So it did an I++, so it incremented from 0 to 1. And then it did the comparison to say, is I still less than 5? It was. So it ran again. And then it did the same thing, came back, incremented. So now I was 2. And then that comparison happened. It realized it was still less than 5. And then it came back. And then it went to 3. And then it went to 4. And then when it hit the 4, and then it incremented, and now I had a value of 5. It did the comparison, and 5 is not less than 5. So this condition was now violated. So it came back to the curly brace and then exited. So whatever else would have been under here, and let's just say I said to console.writeLine, and then this is a nice cool way to get like some space. So if you want like a blank space between 2 lines, you do a console.writeLine, and you want an empty space, you can just do a console.writeLine and it gives you a blank space, right? And I just duplicated by pressing Ctrl D. So just by being on the line, Ctrl D, and that will duplicate the line. And then I'm going to say for loop finished. All right. So let's try that again. So I'm going to execute this one more time. And then here we see that it executed everything. And then when it exited, it continued to execute the rest of the code. So that's once again sequence. So it won't move on until all of what it needed to do inside the loop was done, which was to print this 5 times, to run 5 times, and do whatever I told it to do for 5 times. And then once it finished, it went on to print the blank space. That's that empty console.writeLine, and then print for loop finished. Now I'm going to do a little modification to what it does inside the for loop. I'm going to print another line. So remember that as many commands as we want to repeat, we can put as long as they're inside the 2 curly braces. So I'm going to console.writeLine, and this time I want to print the value of the incrementing variable or the counter, right? So this time I'm going to say counter, and I'm just going to put a colon, and then I'm going to use my interpolation and then plug in that value. So I'm just going to say I. All right. So each time that the loop runs, whatever value I has, I am going to be printing it to the screen just so you can see that it starts off with 0 and goes up to 4, but it would have run 5 times. All right, so let me try that again. All right, so now we see I am a winner and the counter value is 0. Then I am a winner again, counter value goes to 1, then to 2, then to 3, then to 4. So 0, 1, 2, 3, 4 equals 5 executions. All right, so it's good practice to understand why we start at 0, because when we get to arrays and collections, then you're going to understand that the computer actually starts counting from 0. As human beings, we tend to ignore 0 and we start counting at 1, sure, but the computer starts counting at 0. So it's good to appreciate why we would start counting from 0. That being said, I didn't necessarily have to start from 0. I could have started from 50 and counted to 55. And so I could have said the counter should start off as 55 and it should execute until it hits 80. All right, so whatever number of times it's going to go between 55 and 80, or if you do the math and say 80 minus 55, whatever number you get, that's the number of times it's going to execute. All right, so if I just do that quickly, the end result of that is this line, I am a winner, and the counter being printed from 55, which is the value it started with, up until 79, which means that when it hit 80, it violated this condition and jumped out. And that's pretty much it for loop. So this is a very simple example, but I hope that you appreciate it. So I'm just going to reset this code so that when you look at the example, you'll see it. And I'm just going to add sample printing 5 times. All right. So now we have some comments to guide what this is doing. All right, so let's move on to the while loop. So the while loop is what we call a condition controlled loop. And then I appended that with the expression pre-check. So when we do the do while, then you'll see what the pre versus the post really mean. But right now, I'm just going to focus on the condition control. So the condition control portion of it means that it is going to continue executing until a condition is violated, or it will continue to execute while a condition holds true. So with our for loop, it was counter controlled, which means that we're just executing for a finite number of times because we know we wanted to do 5 times. So we specify, or we wrote it in a way to make sure that it doesn't exceed 5 times. However, if we want something to go on and on and on and on until a particular condition is met or violated, then we would use something like a while loop. So the thing is now that with a while loop, you can run into what we call an infinite loop, where if you write the code for the while loop and the condition never gets violated, it will never exit that loop. And so it will run on and on and on, right? As long as the computer is on and whatever conditions are required for it to be running are there, it will just continue to execute. So I'm going to start off by showing you an example of an infinite loop with the while loop, right? So I'm going to declare a simple variable and call it n and give it a value of 0. Then I'm going to say while n is equivalent to 0. And then notice the syntax. We have the keyword while, and then we open the parentheses, and then we put in a condition, just like how we would have done with the if statement, right? So the only difference between it and the if statement is that instead of saying if, we say while, right? So we say while, open parentheses, put in the condition, and then open curly braces with our actions, right? So the way I've written this, n is not going to change from 0. So this is going to say while n has the value or is equivalent to the value 0, I want to do this. So I'm going to write 2 lines. I'm just copy existing lines. So I'm going to print a blank line, and then I'm going to say in while loop, right? So while the loop is running, it's going to print, let me say in while loop, and then the blank line. So it's going to say inside, let me say inside while loop, and we're printing a blank line after that. Now, I'm just going to comment this out quickly so that it doesn't get executed while we run this program, because now I want to focus on the while loop. And you're going to notice that it's just going to continuously print and never stop. So let me execute and show you. And that's what it looks like. So you see it's just printing. It's saying inside while loop, and you can see that it kind of has a blank space. You look at the scroll bar, you see that it's just going on and on and on and on and on. It's never stopping. And that's what we call an infinite loop. These infinite loops are known to break computers. So if your computer crashes when you do this, I'm sorry. But I have a slightly powerful machine, so at least I know that this won't break my machine. But the fact is, if you write poor code in big applications and you get this or end up with this situation, these situations or infinite loops can bring down systems. All right. So you want to make sure that you understand how while loops work, so that you don't make this mistake at any point. All right, so let's exit that and look at how we should write while loops to make the most of it, or to take advantage of the condition while not leading to an infinite loop. Now, our condition is based on the fact that n is equivalent to 0. So it's going to run while n is equivalent to 0. So what if I change this and I said something like while n is less than 5? All right. So while the value of n is less than 5, I wanted to do this. Now, based on the way it's written, this will still be an infinite loop because n is 0. 0 is less than 5, and I'm not doing anything to change the value of n, and so it's going to always be less than 5 and still continue to execute. So that means the one thing I can do to make sure that this gets violated eventually is to make sure that I am changing the value or putting something in place that the value changes at some point, and this comparison will get broken, or this condition will be met or violated rather at some point that is convenient to how we want our program to work. So I want this to print 5 times. Yes, we accomplished something like that with a for loop, but I'm just showing you that I can accomplish something like that with the while loop, but the path to doing so is going to be very different. So I need to now make sure that I am changing the value of n to be something that is eventually will exceed a value that makes this condition true. So I'm just going to add a third line to inside my while loop, and then I'm going to say n is equal to n plus 5. All right, sorry, n is equal to n plus 1. So when I say n is equal to n plus 1, remember we discussed that this could be shortened into just saying n plus equal 1. So now it's going to be adding 1 to itself each time, right? So it's going up by 1 until eventually it will execute, and n is going to have a value that is not going to be less than 5, and so our while loop will exit. So let's test that out. So let me execute, and here we see that it literally printed the right number of times. So just like with the for loop where we started off at 0 and went till it was less than 5, we started off with n being 0, and then we're just checking on the condition that n is less than 5. But there is nothing in the loop or in the structure of the loop, that at least not naturally, that will help us to change the value of n. So we have to do that manually by putting an accumulation. So we call this an accumulator when you make a variable increment by itself plus another value, right? So when I said n equals n plus 1, that's making it an accumulator or plus equal. So now I'm accumulating value each time it runs, and then it eventually will be will meet this condition. Now, this is a very simple and not very practical example. I mean, there are situations you may use this, but a more useful way for using the while loop is to say, compare user input and let the user input violate the condition, and continue to do this until the user violates the condition and the loop will exit. All right. So let's take your experience with an ABM, for example. An ABM will probably always ask you, do you want to continue? If you say yes, it continues. If it says no, and then it repeats the same steps as long as you keep on saying yes. Right. So literally all they have is really a while loop that is allowing you to do carry out operations, and then you can indicate when you want it to stop. And then when you give it the condition that says stop, then it will say, okay, that condition has been violated. Let me move on. So I'm going to modify this and I'm going to say console.writeLine, and I want to tell the user input a number. All right, and I'm going to say 0 to 4. So I'm telling the user to input some number between 0 to 4. And then I'm going to do a read line where I'm going to say n is equal to convert to, sorry, spell convert wrong, convert to int32. And then I'm going to say console.readLine. So I'm accepting user input, and I'm not going to increment because now I have the user determining the value of n each time, right? And I'm going to take out this console.writeLine. Well, let me put it back, and then I'm going to print a screen, you entered, and I'm going to say you entered that number, all right? So let me just put on my $, interpolation. So what this loop is expected to do is that it's going to prompt the user to enter a number. If I enter 0, then it will print you entered 0, and then it's going to come back and it's going to check the condition. Is 0 less than 5? No, it's not. So it's going to say enter a number again, and then it's going to continue doing that until I put in a number that clearly is not less than 5 or will clearly violate this condition. So let's try that. So input a number, and I put in 3. Press enter, you entered 3, and then it's prompting me again. So I entered 3, it printed that I entered 3, and then it did the comparison and realized that this condition is still true because 3 is less than 5. So it went ahead and asked me for another number. If I put in 4, it will do it again. If I put in 1, if I put in -5, as long as a number is not as long as the number is less than 5, then it will continue to do this operation. Now, if I put in 10, it will exit. All right, so let me put in a proper statement to say it has exited. So I'm just taking this previously written one, uncommenting it, and you see keyboard shortcuts just make it easy to maneuver, right? So while loop finished. All right, so let's try that again. So we have 0 to 4, I put 0, I put 5, and then, well, okay, so I entered 5. I did that prematurely, but that's fine. So I entered 0, and it just said, okay, 0 is less than 5, prompt him again. Then I entered 5, it came to the comparison, 5 is not less than 5, and so it just went down to this curly brace and then continued with the execution where it just said while loop finished. All right? So that's basically how we can use while loops, because once again, it's going to run against a condition, and we want to make sure that this condition can get violated and legitimately so, because if we don't do that, then all the operations that the while loop is repeating will be repeated until that computer shuts off. And that can lead to some buffer or memory overload and all sorts of things that we don't want. So when writing condition-controlled loops, make sure that the condition can be violated at some point and legitimately so. Now we move on to our do while, and I did say that I would mention the pre versus post. So the reason we call the while loop the pre-check is that it's going to check this condition before it executes. So if I initialized n to have a value of 5, or let's say 10, then the first thing it's going to do is check, is this condition true? That's the pre-check. Is the condition true? So if n is 10 and 10 is not less than 5, then nothing here will get done. It will just move on to say while loop finished. So that's a pre-check. The post-check will do it before, so it will do the action and then check the condition, right? So let me just write the do while, and I'm going to do the same operation inside the do while, but then we'll see the difference in the execution. So the syntax for a do while is the word do, D-O, then we open and close the curly braces, and then on the close curly brace, you have to say while, and then you put in your condition check. So the while part looks just like the regular while, so I'm just going to copy this and paste it down here. It looks the same way, right? So the only difference is that we say while and then open the curly brace. The do while will say do this action, do whatever is inside the curly braces, and then check the condition afterwards. And then this one requires a semicolon at the end of it. So that's where it can get kind of tricky, because then you see that, oh, no semicolon and semicolon for this one and there. So really and truly, it's just practice that will make you get used to where to put the semicolons and where not to. All right. And Visual Studio is always ready to give you that encouraging red line to remind you that, hey, there's something missing here. So then it's telling you semicolon is expected. You put it there and all is well in the universe after that. So I'm just going to copy these actions quickly, put inside the do while, and put a little space so we can see exactly what's happening. And then I'll put the statement that tells us when the do while loop is finished. All right. So I'm actually not going to comment this out. I'm going to run it. So the value of n is 10. Remember that the pre-check is going to check the condition. If the condition is true, then it will do what we told it to do. And then it will come back and check the condition again. If the condition is not true, then it will not do anything. All right. Whereas with the do while, it will do something and then check. So that means I have the opportunity in this one to change the value of n from 10, and then it can change. Well, it can violate that, or it can make it true. So it will just say, oh, this condition is true. Let's do it again. So it will do it at least once. So let's try that. So I click start, and notice the first thing that's printed to screen is something to tell us the while loop is finished. So, it just skipped it over. As I said, it just checked the condition 10 less than 5. That's false. All right, don't bother with that. Print the blank line and then give me the while loop finished. But then the do while is asking me for the number. So it's doing the action and then it's giving me the opportunity to put in the number, and then it will check the condition. All right. So if we want to do something at least once, it's a repeatable thing, but you want to make sure that it happens at least once, then you want to use a do while. All right. So then I want to input a number, and let's say I input 3, it will repeat. All right. So when I enter 3 on prompt, then it hit the condition and 3 is less than 5. So it said, well, do it again. And then this time I'm going to enter 5, or well, I said 56. That's fine. And I entered 56, which is clearly not less than 5. And so it just went on to say while loop, do while loop is finished. So that's the only difference between the while and the do while. The do while does it at least once and checks after, whereas the while loop will check before it does. And then we remember that our for loop, and I'll just uncomment it before we wrap this up. The for loop is set to run for how many times we want it to run. That's it for repetition statements in C#. Remember to practice and think of scenarios where you may need them. We are going to be using them more in our project, but for now, this is an introduction.